Hi, welcome to Dissolve Chemistry. In the previous video of thermodynamics topic, we have seen regarding internal energy. In this video, we will talk about types of processes. Okay, let us dissolve this particular topic. What do you mean by types of processes? Well, how we categorize these different processes is that, say for example, we know the state variables like pressure, temperature and volume. Okay, so what are the variables which are allowed to change and what are the variables are kept constant? Based on that, we are going to categorize them into various types, and in that first one is isothermal process. Okay, so then second one we call it as what? Isochoric process. And third one is what we call third one is Isobaric process. Okay, and our fourth one will be what we call as Adiabatic process. Okay, first one we will talk about isothermal process. Here the temperature of the system remains constant throughout the process. Means when you do the process, the temperature of the system should not change. Okay, so therefore meaning is what? Delta T is equal to 0. So to understand this, let us consider a system containing diathermic walls, and it is fitted with weightless frictionless piston, and it is confined with 1 mole of ideal gas. Okay, so let us try to understand how we are going to do and what type of how the internal energy is going to vary in this case. Fine. So now Q amount of the heat is given to the system, or it is absorbed by the system, we can say. And as I have to maintain the temperature constant, so when the heat is absorbed, then what happens? Obviously temperature will rise, but I should not allow it to rise. Say for example, you are carrying out the process at 25 degrees Celsius. My temperature throughout the process should remain 25 degrees Celsius, neither 0.1 extra, 0.1 less than that. It should remain constant 25 degrees Celsius. But when the heat is absorbed, then what happens? Heat is absorbed means internal energy will change or temperature also changes, but we are not allowing it to change. So therefore, whatever the Q amount of heat is absorbed, that all must appear as work. Okay, so it has to do the expansion work. Internal energy, as temperature is remaining constant, the change in internal energy will be 0. So therefore delta U is equal to Q minus W. So therefore as delta U is 0, so then what it will be? Q minus W. So therefore Q is equal to minus W. Means whatever the amount of energy is absorbed in the form of heat, that all must appear as what? Work. Okay, or it appears as work in the isothermal process. You should remember this condition. Then let us move for next process that we call it as what? Isochoric process. What do you mean by isochoric process? The volume should remain constant. Okay, volume should remain constant. So therefore change in volume will be 0. So now if you take a piston, weightless frictionless piston, 1 mole of gas, right? Now what we have to do? We have to lock this piston, means it should not be allowed to move because I have to maintain the volume constant, means it should not change its volume. So anyway, it is a gas. Now suppose if it absorbs heat, okay, Q amount of heat is absorbed by the system, but we are not allowing it to do the work. So therefore whatever the amount of energy is absorbed, delta U is equal to Q minus W. Say for example, But as volume is not allowed to change, so therefore work done will be 0. So therefore whatever the amount of heat is absorbed, that all leads to change in the internal energy of the system. You should remember that heat is given out or heat is absorbed at constant volume, that leads to change in the internal energy of the system. Okay. So next we will talk about, so you should remember these conditions. Okay. Q is equal to minus W, isothermal process. Delta U is equal to Q, isochoric process. Then the third one is isobaric process, means we have to maintain the pressure constant. Pressure should remain constant throughout the process. When the pressure should remain constant, okay, means suppose internal pressure is 1 atmosphere. During the process, throughout the process, it should remain as 1 atmosphere, 1 mole we are taking the gas. Say same conditions we will maintain. 1 mole of gas confined in a cylinder with weightless and frictionless piston. Now suppose if you give heat energy to the system, a Q amount of heat is absorbed at constant pressure. Now to maintain the pressure constant, now whatever the heat is absorbed, then what happens? Obviously if you allow it to change, its pressure will be increasing. Suppose if you are not changing the volume or prior to that, what happens? Pressure will increase. So but I have to maintain the pressure constant, 1 atmosphere. So therefore internal energy of the system rises. Okay. Further what happens? It will do certain amount of the work also. Whatever the heat is absorbed, so that leads to change in the internal energy, and it will do some work to maintain the pressure constant. So therefore your delta U is equal to what? QP. QP means heat absorbed at constant pressure will lead to do some expansion work, as well as internal energy also increases. I can show like this. Whatever the amount of energy is utilized, that will be delta U plus W, means internal energy, as well as work is also done by the system. Okay. So that is what we can say. Here isochoric process, we will say QV we will mention. Okay. Heat absorbed at constant volume, that all leads to only change in the internal energy of the system. Next we will move on to the next process, very important, that is adiabatic process. Now this adiabatic process, it is very interesting that as word itself is saying adiabatic process, meaning is what? So the system will be isolated. Okay, it is not made with diathermic walls, it is made with adiabatic walls. Okay, so or we call it as what? Thermally insulated walls we have to use to make it a system. So now when you confine the system thermally non-conducting, then what happens? Heat given out or in of the system will be 0. Neither heat is absorbed by the system nor heat is given out of the system. So therefore, if the system does the work, okay, so therefore Q is equal to 0, means change in heat content of the system will be 0. Alright. So then suppose if it is doing expansion work, then it has to do with what? Now supply route is being cut off, means heat is neither given or taken. Now it has to utilize its internal energy, means there is any external source is there of money, then if it stops, then it has to utilize its bank balance. I have to utilize my bank balance. Similarly, here system has to do, if it does expansion work, then what happens? Internal energy will decrease. Okay, delta U will be minus. Okay, when work is done, or we call it as minus W. Expansion work if it does, then what happens? Internal energy of the system is going to decrease, because already Q is 0, already condition we have mentioned. Now suppose if compression work is done, if you compress the gas, then what happens? Your internal energy of the system is going to rise. Okay. So this we call it as what? Adiabatic process. You should remember these conditions, okay, well, which are very useful in further aspects of the thermodynamics where we come across, we will see that one. I hope you have understood all the 4 processes. Okay, last one, another one process, we call it as what? Cyclic process. Okay, any process it may be. So now if the process of, for example, what I am doing, I am expanding the gas, again I am compressing, I am and expanding, means in multiple steps I am changing the system or I am doing the process. And after doing all the changes, if I come back to the same state what I had initially, so then that process is called cyclic process. Overall change will be 0. Okay, you are doing expansion work, compression work, okay, expanding, compressing and all that. After doing all those processes, if you come back to what the initial state it has, then we call it as what? Cyclic process. Okay, you should remember this. So with this we will conclude here. Thank you for watching video.